Hello aspirants, my greetings to all of you, my warm welcome. So I am Rishi Bhargava and today I am going to discuss about Pythagoras Theorem, right? So you are at Unacademy and you know Unacademy happens to be India's largest learning platform. And why Unacademy? You know all the advantages. See, these are the basic advantages. Widest choice of educators, flexibility to change courses, unlimited views on the lectures and all other, right? And then for UPSC, you know that we have got one of the best teams of trainers around. These are the few names. Then guys, you can join Unacademy subscription plus an iconic, right? You can use the code YTUPSE to get 10% off for the subscriptions. Similarly, you can also go for the combo subscription. You can use the same code and you would get the same discount. We have Unacademy optional subscription as well, where again using the same code you would get a 10% flat discount. Now here is a chance for you to get 20 booklets for UPSC preparation, a great initiative by Unacademy. So it covers each and every topic that is being asked in UPSC, guys, right? So please, we have started a batch on September 29th for UPSC CSE. It's a bilingual batch. All of you are most welcome to join this batch, right? Now please guys, just you can avail EMI options as well. That's really a great initiative again. So all you need to do is give a call at 8585858585 and get EMI options for the subscription. So my name is Rishi Bhargava and I would love to share a lot of shortcuts, lot of techniques and add value so that you guys can clear CSAT, right? So CSAT happens to be Civil Services Aptitude Test, and this is my you guys can join us at Telegram channel as well, IAS Icons 1, and my community is Bhargava Rish, so you can follow my community as well. Now CSAT basically when they talk about CSAT, they say it's general mental ability. All right, now we are going to talk about general mental ability, and I have given you a lot of videos on numbers, on shortcut techniques, on calculation techniques, on basic counting. So today I am going to discuss something about geometry. This is going to be an awesome trick on geometry, and thus everyone knows about Pythagoras theorem. So I'm going to talk in details about Pythagoras theorem and how to use Pythagoras triplets to solve questions just like a click. We just actually don't need to apply Pythagoras, we can do it otherwise as well. So this would be today's discussion, guys, Pythagoras theorem and its application. So I hope most of you are ready for this, right? Everyone knows Pythagoras theorem is basically applicable to a right angle triangle, right? Just have a look at it. If you have a right angle triangle, right, I name its hypotenuse as A, and hypotenuse is a side opposite to the right angle triangle, and in a right angle triangle hypotenuse happens to be the longest side, and I name base as B and perpendicular as C. Then I think this is one result every student should know, and every student knows also, remembers also, isn't it? What is area of triangle? Half base into height. What is Pythagoras theorem? Sir, A square is equal to B square plus C square. A square is equal to B square plus C square is your Pythagoras theorem, isn't it, guys? All good, right? So if we are comfortable with Pythagoras, then what about if A square What about if I say, guys, what if a square is greater than b square plus c square? I don't know whether you have thought about this or not. A square is greater than b square plus c square. In this case, where a is the longest side, where a is the longest side of the triangle. In that case, you would get a obtuse triangle. Obtuse triangle. So what's an obtuse triangle? An obtuse triangle is a triangle in which one of the angles is greater than 90 degree. So this is the shape that you are going to find, right? This is side A and this is B and this is C. Obtuse angle triangle, one of the angles is greater than 90 degree. You can see this angle is greater than 90 degree. So if a square is greater than b square plus c square, it's an obtuse angle triangle. If a square is equal to b square plus c square, it's a right angle triangle. And if I say a square, which is the longest side, is less than b square plus c square, in that case it's an acute triangle. It's an acute triangle. What is an acute triangle? Each and every angle is less than 90 degree. So in this is the shape when a square is less than b square plus c square. Suppose this is A, this is B, and this is C. So we got three results now that we can easily say that we know what is a right angle triangle, we know what's an obtuse angle triangle, and we know what's an acute angle triangle, right? Good enough. Then, what are Pythagoras triplets? Triplets. These are those three numbers. These are those three numbers that satisfy Pythagoras theorem, right? We call it Pythagorean triplets as well, right? And they are integers. So whatever I'm going to talk about integral values only. Integral values only. Now Pythagorean triplets are those three numbers that satisfy Pythagoras theorem, right? Remember that. So for example, right, one of the basic Pythagorean triplet is 3, 4, 5. 3 square plus 4 square is 5 square. From left to right, if you check out from left hand side to the right hand side, we actually go from the smallest to the biggest, right? And then please pay attention. So we call it a basic Pythagorean triplet. Now this is something you may not know at all. Now please pay attention. If I add 2 to the side and 8 over here and 8 over here, I get 5, 12, 13, and just check out 5 square plus 12 square is 13 square. Just check out please. 5 square is 25, 12 square is 144. 25 plus 144 is 169, which is 13 square. Sir, what is happening now? Please see this. I think you may not have seen it. One more time. See, I add 2 over here and then I add 12 over here and 12 to this side. Now I get 7, 24, 25. Just check out what is 7 square 49, 24 square 576. 576 plus 49 is 625, which is 25 ka square. Pythagorean triplet. So there is a sequence of Pythagorean triplets which actually nobody knew, right? So one more time, sir, one more. So add 2 over here, add 16, you get 9, 40, 41. And then you realize 9 square is 81 and 40 square is 1600. 1600 plus 81 is 1681, which is 41 ka square. So guys, were you aware of it? Yeah, no, you were not, right? And you keep on adding 2, you keep on getting Pythagorean triplets. So you get 11, 60, 61, and so on. The best part is, listen guys, we are talking about Pythagorean triplets starting with the odd number. 3 is odd number, 5 is odd number, 7 is an odd number. So you know that you are adding 2 to the left hand side. And otherwise, if you check, over here is 8, 12, 16, 20, next would be 24 and so on. To the other two sides, we keep on adding table of 4. Table of 4 starting with 8, 8, 12, 16, 20, 24, 28, 32, 36, 40, and you keep on getting Pythagorean triplets till infinity. Till infinity. Right? So we call it Pythagorean triplets starting with odd numbers. But then, you know, this is impressive, I know, but at the end I realize how to use it in competitive scenario, isn't it? That is actually really important. Knowing a result is good, but knowing how to apply it is something really, really important. So I hope you have made a note of this. Now, two questions that arise in my mind. Two questions that would arise in my mind. I'll talk about those questions, but the brilliant part of the series is not that it is giving you infinite Pythagorean triplets downwards. It is giving you infinite Pythagorean triplets, series of infinite Pythagorean triplets downwards. The beauty lies in each and every participant. So please pay attention over here. This itself, 3, 4, 5, give you infinite Pythagorean triplets. Multiply by 2, 6, 8, 10. 6 square plus 8 square is 10 square. Multiply by 3, 9, 12, 15. 9 square plus 12 square is 15 square. Multiply by 4, 12, 16, 20. Pythagorean triplet. Multiply by 5, 15, 20, 25. Pythagorean triplet. So every member of this series, every Pythagorean triplet of this series also give you infinite Pythagorean triplets. So this is a series of infinite Pythagorean triplets downwards, but each member when multiplied by integers multiply by 2. 10, 24, 26. 12 square plus 24 square is 26 square. Yes sir, you are absolutely right. It would also give you infinite Pythagorean triplets. Right? Now this happens to be amazing series. Nobody knew about it. Then it's not over, it just started. The two questions that arise in your mind, sir, these are those Pythagorean triplets which are starting with the odd number, the smallest possible odd number. 3, 4, 5. 3 is the smallest out of 3, 4, 5, and 3 is odd. Right? Similarly, check out 5, 12, 13. 5, 12, and 13. Out of 5, 12, and 13, 5 is odd and 5 is the smallest. So don't you think there would be a Pythagorean triangle starting with smallest even number as well? Yes. One question which is genuinely good, right? And second thing, right, sir, on integers, you know, are these unique? These Pythagorean triplets, are they unique? Which means, do you think 3, 4, 5 is the only Pythagorean triplet, 5, 12, 15 is the only Pythagorean triplet on integers? Or are there many more? Isn't it? Are there many more? These are the two things that strike in your mind. So first important aspect is, let's answer the second one, right? If a Pythagorean triplet is starting with the odd prime, 3, 5, 7, it is unique. I am talking about Pythagorean triplets on integers. Right, I am not talking about Pythagorean triplets on fractions. No, there may be a Pythagorean triplet starting with 5 and remaining two sides are non-integers or fractions. It may be possible, but 5 and other two sides integer, there is only one unique Pythagorean triplet, 5, 12, 15, 13. 5, 12 and 13. I hope you keep this thing in mind, which means 3 has only one, 5 has only one, 7 has only one, because 3, 5 and 7 are prime numbers. Alright. 3, 5 and 7 are prime numbers, right? But if you talk about, now you talk about 9. 9 is an odd number, but it is not prime. Then it is not unique. See, one Pythagorean triplet is 9, 40, 41, which many of you don't know. Starting with 9, 9 being the smallest, but there is one more. 9, 12, 15. See? Because now 9 is a composite number, so it would, one Pythagorean triplet would come out from the factor of 9, which is 3. Right? From the factor of 9, which is 3. That is more important. Now I have answered your uniqueness wala question. Now the second question that arises in my mind, and maybe in a lot of you guys would also thinking, sir, what about even number? Don't you think there can be a Pythagorean triplet starting with an even number? That even number is the smallest out of all three sides. Yes, there is. Secondly, again, I am making a question out of a question. Second question now that may arise is, sir, if I want a Pythagorean triplet starting with, suppose I want a Pythagorean triplet starting with 17, do you think I am going to draw this series till 17? Yes, it is going to give you result. But do you think that I am going to draw it till 17? So these two questions are now answered by the smartest of the smartest trick that I am going to discuss now. First, if you talk about 8 as one side of a triangle, 8 is one side of a triangle which is a right angle triangle and it is the smallest side, right? So sir, what are going to be the remaining two sides? So I am writing trick for even number. If there is an even number, what is the trick? Check out. What is half of 8? Sir, it is 4. What is 4 square? Sir, it is 16. Which is a number bigger than 16? Sir, 17. Number, integer, smaller than 16, 15. So in that case, guys, 8 square plus 15 square is 17 square. 8 square plus 15 square is 17 square. Great trick. Huh? Really awesome trick, sir. One more. Suppose I want a Pythagorean triplet starting with 12. So what is 12 square? Right? What is 12 ka half? 6. What is 6 square? 12 half. So I am writing 12 ka half is 6. What is 6 square? 36. What is the number bigger than 36? 37. Smaller than 36? 35. So 12 square plus 35 square is 37 square. So 12 square plus 35 square is 37 square. So this is an amazing trick which you may not find anywhere, guys. Amazing trick. Now we are able to find Pythagorean triplets starting with even numbers, and we don't even require to remember a series. No, we don't require to remember a series, isn't it? Sir, one more example. Suppose I want a Pythagorean triplet starting with 20. So what is half of 20? It is 10. What is 10 ka square? 100. So 101 and 99. So 20 square plus 99 square is equal to 101 ka square. Right? Right? Now you may check it. If you have done squaring with me, what is 101 ka square? It is 10201. And what is 99 ka square? It is 9801. And what is 20 ka square? It is 400. So if you add these two, you will definitely get this. Yes sir, it is right. Right hand side is equal to left hand side. So have you ever imagined a Pythagorean triplet starting with 20 having values like this? No. So for even number, what we do? We say half of the number and then square of the number and the bigger number and the smaller number, right? Now amazing thing to notice over here is when it is starting with even number, 8 is a even number, remaining two sides are odd. Remaining two sides are odd and they have a difference of 2. They have a difference of 2. Just make a note of this, right? So when it is about starting with an even number, the best part is that remaining two sides are odd and there is a difference of 2 in the remaining two sides. And yes, I'm going to put a question on this only and then you are going to say, yes sir, this is the way questions are framed, right? This is the way questions are framed. So let's talk about, sir, now you have given us a beautiful trick for even number, a Pythagorean triplet starting with the smallest even number, right? So is there a trick for odd number also, or we have to depend upon this table to find Pythagorean triplet starting with odd? Now think about it. If there is a trick for even, why not there would be a trick for odd? But now my observation says, now see, as I keep on getting the results, I keep on observing certain things. So my observation over here is stating a very simple thing. Whenever it is starting with odd, one number is even, another is odd. Other two sides, one is even, one is odd. Right? One is even, one is odd. Clear? And then listen, the difference between the remaining two sides. The difference between the remaining two sides is 1. See, the difference is 1. So guys, now what do you suggest? Is there a method? So let's talk about it, right? Yes, there is a method. So if you want a Pythagorean triplet starting with the odd number, right? Just have a look at this. Suppose I want a Pythagorean triplet starting with 11. Now reverse the process. Over there, we were talking about half the number and square the number. Over here, first square the number. So 11 square is 121. And what is 121 by 2? It is 60.5. It is 60.5, right? Now, just let me do it again with a black pen. I say 11. So what is 11 square? 121. What is 121 by 2? It is 60.5. So an integer greater than 60.5 is 61. Integer smaller than 60.5 is 60. So remember, 11 square plus 60 square is 61 ka square. 11 square plus 60 square is 61 ka square. Wow, we got a trick again. Now you may ask, sir, why did you showcase that lengthy table? Because I wanted to tell you that there exists certain symmetry in geometry also, isn't it? There exists certain symmetry in geometry as well. Come on guys, that is really important, isn't it? One more, sir, one more. So let's find a Pythagorean triplet starting with, suppose you say 15. So what is 15 square? 225. What is, just a minute, let me erase this now. I hope you have written it, guys. What is 225 by 2? So 200 by 2 is 100, 25 by 2 is 12.5. Sir, it is 112.5. A number bigger than this, 113. A number smaller than this, 111. So 15 square plus 111 square is equal to 113 square. Alright, you want to check it, you may check it also, guys. 15 square is what? 225. What is 111 ka square? 111 plus 11 is 122 and 11 ka square is 120. So 122. So 1, 2, 3, 2, 1. Now 111 is a number whose square will give you palindrome, right? So see, 11 ka square is 1, 2, 1. 1 ka square is 1, 2, 3, 2, 1. 1 ka square is 1, 2, 3, 4, 3, 2, 1, right? So what are palindromes? They are the numbers that are read from the front and the back. The value comes out to be same. So 111 is 1, 2, 3, 2, 1. And then what is 113 ka square? 113. Again, I'm very good at squaring. Just check the videos that are given. You would also be pretty good at it. 113 plus 13 is 126. And 13 ka square is 169. 12769. 12769. So just add on, you will get the same thing. Check out. Yes, sir. So now we are so sure that there exists that symphony in geometry as well, that symmetry of numbers in geometry as well. The first people to think like that and find these things were not modern people, they were Egyptians. Pyramids, the symmetry that pyramids have is basically dependent upon right angle triangle geometry. All right. So don't take it as my results. Probably you would also understand that these results have been discovered years and years and years, thousands of years back. Clear? Now we are so sure about Pythagoras theorem on integers. So why are we discussing it? Right? There has to be a reason. Okay, sir, what is the reason we are discussing it? So we'll talk about the reason. Listen, the reason is this. I saw a question and I was really impressed with the question, right? And the question was, he says, so I am not going to write a question, rather I'm going to, draw the diagram of a question and make you guys understand it. He says, a stair leans against a wall of height 8. A stair leans against a vertical wall of height 8. So there is a vertical wall, height 8 meters. All right. So this is a scenario. See, this is your wall and this is your stair and this is a vertical wall. This is 8. First statement is giving you this. First statement is giving you this, right? And then, secondly he says, so this is your stair, right? Secondly he says that if the bottom of the stair is taken 2 meters away from the wall, if the bottom of the stair is taken 2 meters away from the wall, the top of the ladder falls to the point where these two meet. So top of the ladder falls to the foot of the wall. All right. So what happens now? Secondly, he's saying, so I'm just changing the color. He's saying that when you take this stair 2 meters away from the wall, when you take this stair, the bottom of the stair 2 meters away from the wall, the top of the stair comes to the bottom of the wall, right? And the question is, find the length of the stair. What would be the length of the stair, right? So either though you apply algebra, geometry is beautiful because they mix a lot of geometry with algebra and they give you beautiful answers. So I'm solving two ways. So I say this is my initial picture. This is 8. I say let the length of the wall be x, right? Let the length of the stair be x, sorry. In that case, if I apply Pythagoras, this would be x square minus 64 as the length of the base, right? So first thing, and then suddenly we realize that the bottom of the stair is taken 2 meters away from the wall. So now this is the situation 8, and what happens is that this x falls down, and what was this? What was this length? This length was under root of x square minus 64, and this length was 2. So ladder, as it falls down, the length of the ladder remains same, but now you see that the ladder is equal to under root of x square minus 64 plus 2. If you are a smart guy, you would not use any algebra over here, solutions over here. From the options, you'll pick one option and fit in over here, and you get your answer, right? One thinking, one way of solving. And I really appreciate algebra as a solving solution, and a lot of engineers, a lot of math students will depend upon algebra. I understand that. But now think of why the question is being framed. Think of why the question is being framed. Because the question setter knows a very simple result, which now you as my students also know. See, question setter knows that if this is 8, then remaining two sides have a difference of 2. Now he immediately thinks, my student or you guys would immediately think, yes sir, you had told us. So what is 8 square is 4 and 8 ka half is 4 and 4 square is 16, 17 and 15. So you say that 8, 15, 17 are Pythagorean triplets, and you try to fit in 15 and 17. Now listen, if I take the ladder 2 meters away, 15 plus 2 would be 17, which means this is the diagram. The length of the ladder is 17. We call it fixing up of Pythagorean triplets. We call it fixing up of Pythagorean triplets. So if you are intelligent, you would automatically find a triplet associated with 8, and with the options you would get an answer. Now you have to understand this is a way to go. That is the reason, you may apply algebra and many of you would be solving like, sir, this is x minus 2 is equal to under root of x square minus 64. Whole squaring x minus 2 ka whole square is equal to x square minus 64, which means x square plus 4 minus 4x is equal to x square minus 64. So see, you have to have a lot of work, right? And then you would get your answer. And this is going to give you x is equal to 17 again. So either you pick x from option and put it over here, or fix up a Pythagorean triplet, right? So we call it fixing a triplet in a right angle triangle. If you are smart, you're gonna remember me for a long time with this result, right? And then guys, so we are offering UPSC CSE mains test series for 2023. So please guys, come join, subscribe and get the best. And if you want to score more than 325 marks in UPSC optional, we are providing anthropology, public administration, geography and mathematics as optional subjects, guys. Please check on Unacademy platform. And then just check out the doubt browser feature on your app. It's an excellent innovation by us. So guys, I hope that I have added value to your knowledge today, because a lot of time people think that there are only shortcuts in numbers or calculations. No, there are shortcuts everywhere. All you need to do is attend my classes. My name is Rishi Bhargava, and please visit IAS Icon channels and please subscribe. Thank you so much. My greetings to all of you, and at the end, Jai Hind.